Rodriguez, Olivier, Strauss, and Martin Rabier about an ad hoc study on soldiers' calibration procedures in VR. And this is Jean-Daniel Taupiac.
Okay. Hello, everybody. I'm very happy to be here and share with you this work and this specific study we made during my PhD studies. I'm Jean-Daniel Taupiac. I come from the University of Montpellier, and I make my PhD study both in a company which is called Capgemini. So this is the French Infantryman, and as you can see, the French Infantryman is equipped by the FAMAS system, the FAMAS rifle, sorry, and the FAMAS rifle is extended by some different device inside the system, which is called the FELIN system. One of these devices is this device you can see here, which is the ear sight. The infrared sight, sorry, and this device allows night and camouflage vision. And in order to use it, you have to put your eye just in front of the eyepiece and interact with the side buttons. There is side buttons here, and there is inside different menus. The FAMAS is extended with a remote control, which is here. And the soldier can interact with the device with these two ways. So one of the main tasks the soldier have to learn is to calibrate this ear sight. In order to do that, the soldier should shoot 5 cartridges on a target and calculate a thing which is called the PMI for a medium impact point with this 5 cartridge. And with this value, it will see if the PMI is the targeted value, which is the bottom of this triangle. Today, the trainees are training on a 2D software you see here, which is on which you can see different elements in order to interact with the ear sight. And the process for the French army is to practice until making no mistakes and replay until making no mistakes in order to be able to, after that, go on the shooting range and make their first procedure in real situation. So the problem is that instructors, when we asked with them, said that there could be a lot of issues, and they didn't know if the skill development is really guaranteed with this 2D software. So they said that learners have to do too many replays. They have to do. They ask if maybe if they are doing mechanical repeats, which do not guarantee the development skills. And it seems that they spent too much time on the shooting range for their first procedure. So as we know, VR has shown relevance for training, especially in skills transfer and particularly for technical and maintenance procedure. In the military area, there was a lot of different field concerns by virtual reality works. But we didn't find some works about specific rifle maintenance in VR. What we know from the literature is that simulation fidelity tends toward training effectiveness, and especially something which is called passive haptics. What we know is that passive haptics enhance sense of presence, and what we also know is that sense of presence enhance acquisition and transfers of knowledge. And a last point we underline from the literature analysis is that some work use off-the-shelf systems which allow especially a low initial and operational cost. And in this field, in military area, making a custom device is very expensive. So we want to try if VR could be a solution to these problematics from this literature analysis, and we implemented a VR prototype by modeling a shooting range in virtual reality. And we use also off-the-shelf systems Here you can see a support from the game industry for an HTC Vive, on which you can plug your controller in order to make a rifle. And that was cool because it was on the same size than the FAMAS. And in order to let the trainee make the procedure on the prone position, in real situation we added a bipod. In order to simulate the remote control of the FAMAS, we divide the Vive controller in 4 areas, and we added an adhesive mask in order to find the different buttons position. And because we wanted to compare it with the 2D software, we used the same rule present in the 2D software. So there was no shooting precision required. The shoots were randomly generated, and the correction values were also indicated as on the software. And finally, the number of iterations until the process ends was of 3. So we identified 3 types of error possible. The first one was procedural error, which means that the trainee tried to do something which is not allowed at this stage of the procedure. Correction values when the trainee misunderstood or miscalculate the value, or maybe make confusion between the different values or the signs. And finally, button error, on which means that the trainee used the wrong button in order to do something. So I propose you to... Oh, sorry. Okay, I propose you to see the prototype in action. So as you can see, the soldier is taking the prone position, and when he moves his head and the headset close to the rifle, on the right eye is displayed the camera view, as we can see here. So as I said, you have to move inside the menus by using the remote control and choose the distance on which is the target, and after that shoot is 5 cartridge. I don't know if it's visible, but here are the shooting points which are generated randomly. And when he did that, the trainee have to stand up and go to the target in order to see the correction values. So we added a teleportation zone, and when the soldier is in front of the target, he sees the correction values, 2 values, one in direction and one in eye. So he go back to the rifle and have to enter the correction values inside the system, inside the site. So as you can see, is modifying the values here. So we wanted to experiment it for 2 main things. The first thing was we wanted to test for users if the fidelity was an out and if the conception choices were good. We also wanted to analyze if there was impacts on learning, such as motivation, number of mistakes made, error awareness from the learners, and also self-confidence. So we divided our population between 2 groups, one on the VR learning methods and one on the 2D software methods. The goal was to let the different groups make their first iteration on the VR prototype or on the software, and after that make replays until making no mistakes on the software. So for the VR learning method, we make user tests. We ask them to rate the rifle, the remote control, the sight, menus, and the moving method. And we also ask them to answer to an IPQ presence questionnaire. For both groups, we wanted to see learning effects by Likert survey about pleasure and interest, intrinsic motivation to repeat the training task, and also to their self-confidence. And we also asked them to estimate the number of errors they made, and we trace all these data on log files. We ended for the VR group on an open interview where the question was to give us relevant feedback you want. And after that, as I said, they have to iterate on replay. We draw some hypotheses, which are, we suppose that learners will be more intrinsically motivated in VR. They will also make fewer mistakes on their replays, and consequence of that, they should need less replays in order to go on the situation that they made no mistake. And we also suppose that they have a better awareness of their mistakes and a better self-confidence. So we made an experiment on the Draguignan military school on learners and also on instructors in order to see if there are some differences showing that there is a gap between the reality and our prototype. So here is the results. For user test, as you can see, the menus and the moving method were well rated, but we have a moderated rate for the rifle, the remote control. We have seen some fidelity lags with these off-the-shelf devices. For example, when they took the prone position, the soldier used to grab strongly the rifle, the handles of the rifle, and because the support was magnetized, the controllers were moving lightly and making it very unstable. And the other problem was the solution with the trackpad and the adhesive mask. People have a lot of trouble to find buttons. And these results are confirmed by the open interviews. The gun was also felt too light. They have, as I said, difficulties to find button. They desire to see their hands, to see their thumbs. And other interesting things, they're seeing that the trigger of the controller is not like the real trigger, which is a little more stronger. And they complain about an absence of recoil after the shot. For the presence results, general presence and spatial presence are not so bad, but more moderated involvement and experience realism are well underrated. We suppose that these results are possibly linked to fidelity lags. As I said, we also make tests on instructors, and what we've seen was that there is no statistical difference. On learning efforts, we got significant results for the pleasure and interest, for intrinsic motivation. Oh, I'm late. So VR users were more motivated and felt more pleasure. And what is very interesting is that when people using the 2D software still continue on the replays to make errors for procedural errors and correction errors, people in VR doesn't do mistakes on their replays, except for the button, which is explained by the fidelity lags we showed before. So consequences of this is that people which were in VR need less replays, and we didn't found significant result for awareness and self-confidence. So that's made validating our first and third hypothesis, and partially validating our second hypothesis. Other observation, and I have to be fast, is that some people using the VR systems allows to highlight 2D software limits. Some errors which were not possible in the 2D software shows off from the VR experience. And two other things interesting was that trainees used to be diligent on their shooting practice, very focused, so even if we say them that they don't have to be, and that there is no shooting precision. And the second interesting effect is that a lot of them said that they felt a sensation of calm to being on the shooting range, and we are thinking about how to use it. Should I continue maybe 2 minutes? I just have to conclude and show the limits, if you let me. Thank you. So some of the limits are from the procedure simplicity and the fact that our subjects were trainees for lieutenant school, which has a very high education level. So we suppose that maybe with another population we should have more pronounced results. And in order to work, obviously we want to resolve this fidelity lags by, for example, using demilitarized equipment and different other things we have to try in order to produce more studies. So to resume, in conclusion, passive haptics were insufficient for this use case. VR can improve intrinsic motivation to replace the rifle maintenance task. And VR learners made no error when 2D software continued to make some. And VR can also be used in order to see where are the limits and which kind of error are not tracked by a 2D software. So thank you for your attention.
So thank you very much. This was the last talk. We are running slightly over time. For the whole time already, but now with you, maybe we can ask questions during the break now. You are lucky because the break is right after you. So maybe you can have some conversations there and otherwise enjoy the conference.